Why do some telescopes use mirrors instead of lenses? Imagine trying to look at the stars through a giant glass piece. It sounds simple, but as telescopes get bigger, using lenses becomes a real challenge. Some telescopes instead use mirrors, and there are good reasons for that. First, making large lenses is very expensive and complicated. Lenses need to be perfectly smooth and free of flaws all through their thickness. When they get bigger, this becomes even harder and costs a lot more money. Mirrors, on the other hand, only need a smooth, reflective surface on one side. This makes them easier and cheaper to produce in large sizes. Second, lenses often cause a problem called chromatic aberration. This happens because different colors of light bend differently when passing through glass, creating blurry images with colored fringes. Mirrors reflected all colors equally, so images stay clear and sharp. Third, supporting large lenses is tricky because they must be held at the edges, which limits their size. Mirrors can be supported from behind, making them more stable and less likely to sag under their own weight. This support system allows for much larger mirrors, which means telescopes can collect more light. The more light a telescope gathers, the better it can see faint and distant objects in space. That is why the biggest telescopes in the world are reflecting telescopes with huge mirrors. These large mirrors help scientists discover new planets, stars, and galaxies. From a practical point of view, building big mirrors is smarter and more cost-effective. It also helps countries and research institutions stay at the forefront of space science. Investing in mirror-based telescopes means better images, larger sizes, and more powerful tools to explore the universe. So, in short, mirrors are used instead of lenses because they are easier to make big, avoid color problems, and support larger sizes that improve our view of space.